Okay, well, welcome everybody. It's great to see everyone. This is our weekly conversation about the future of work, and we are pleased to have Joe Gabbard with us. Just quickly, I would like to thank the NSF for partially funding this effort, and the organizers are Linda Boyle, John Lee, Rafaela Sadoun, or Chair, Manfred Chelgi, and myself. Logistics, this is recorded, and then questions, please put them in the chat, or it will look at those and call on you. Okay, so today our guest is Dr. Joseph Gabbard. He's the director of the Cognitive Engineering for Novel Technologies, or Cogent Lab, at Virginia Tech, where he's a professor in the Grado Department of Industrial and Systems Engineering. So welcome, Joe. And looking at your work, you're interested in creating augmented reality systems with they're usable and where the user experience is excellent. So how much do we know about how well the current AR systems work for users?
Thank you for the question, Andrew, and more broadly, thank you for the invitation to speak with the group today. So if you don't mind, before I answer the question, I'll repeat the question, but just give a little bit of quick background on myself for context. I followed a sort of, I think like maybe there is no canonical standard path through academia, but I got my degrees in computer science actually at Virginia Tech with a heavy focus centered on human-computer interaction. So my research at the thesis level and dissertation level were in the usability of virtual and augmented reality interfaces respectively. And I don't want to like say how old I am, but it was at the beginning. I mean, it wasn't like Ivan Sutherland beginning, but it was early, right? And that's actually been a blessing in hindsight, because it's allowed me to kind of watch both virtual and augmented reality kind of grow up. But as I progressed through my career, I was actually a research scientist for quite a while and did a lot of usability work that kind of crossed boundaries from websites to mobile interfaces, and then back into VR and AR when I could. But it wasn't until 2013-ish that I got a tenure track faculty position. It wasn't in computer science, and it almost was at the last kind of minute. Virginia Tech's Department of ISE, and in particular the Human Factors program, had a position open, and I was lucky enough to be selected. And since then, I've been extremely lucky to work with numerous graduate students that are just excellent. I think honestly that graduate students are kind of not lifted up enough by faculty. We cannot do what we do, period, unless you can sit in your office and just write papers all by yourself, which there are faculty that can do that. I cannot. This graduate students make everything go around, and not only make the work happen, the relationships are kind of personally rewarding for me. So anyways, the bottom line is that in terms of my thinking on these topics, another really nice surprise from me joining Human Factors was that I was able to learn new things that I hadn't been, and I still haven't been properly trained in Human Factors, but I've been sort of applying what I'm learning along the way to my core knowledge of HCI in the VR AR space. And so that's kind of the story of how I've gotten to where we are today. So your question though was about usability in AR systems, and how much do we know about how well the current systems work. So I'm going to break the current systems into two pieces, maybe. There are a number of AR systems that are finally fielded and out there, as opposed to in the lab, which is the other class of interfaces. So I'll give an example. So the other day I got an email from a friend of a friend, and they work at some manufacturing facility around the Blacksburg area. And they said, we just got this new super expensive piece of equipment. It's arriving in 3 weeks, and there's a whole installation process that if I have a HoloLens, then I can use this installation process and I can have a tele expert connect in and help us install this thing. But they didn't have a HoloLens, and so they were asking me if they could borrow one. And I said yes, of course. But to me, this was sort of a so my next question to this person was, well, can we come observe? Because to me, I think this is kind of really interesting. I outside of trade shows, I have not been exposed to too many actual AR systems, being used like firsthand in the wild. Of course, I've read about some of them, but so I don't know. I can only posit how usable they are, and so my supposition would be that like any other software, if the scope of what the tool does is narrow enough and the right team designed and built it, and heaven forbid you need a lot of training, or but if it's a specialized situation, you of course do, then I suspect that they work okay. Otherwise, I wouldn't be getting phone calls, like I just described. Having said that, though, I also posit that there are a lot of bad systems out there, and that's not because there's bad designers, or interface designers. It's because we really don't know what we're doing yet. This is, I'm going to say some things that are kind of like strong, but in my opinion, we don't really know what we're doing yet in terms of design. And I've got more to say on that, but and I think I've identified some of the underlying problems on why we don't know what we're doing. It's partly the lack of information, and we can talk about that, but it's also part of, I think, almost a natural progression.
So I think that's my next question, right? I mean, you are looking into, well, how do we evaluate them? And I think one issue that you bring up is the lack of access to exactly where these systems are being used. But then, can you tell us more about what is your thinking? What are those measures that we should look at? Are they physiological? Are they performance? Are they subjective? What do you think about how do we actually evaluate AR systems?
So I actually say, again, the world according to Joe, which is dangerous. I actually think we know more, or we're better equipped to assess than we are to design. And I know, that we can get into splitting some hairs about, evaluation is part of design. And so I teach UX courses, I understand that. But so what I like to do is kind of circle back a little bit to the design part, and then get to the measures of effectiveness, so to speak. So here's the situation as I see it. We are effectively applying two-dimensional GUI interaction. GUI does GUI visual design and interactions. Right now, we're applying those into the AR space because that's what we know and what we're familiar with. And if you actually go back and trace, which is something that I've done, and I've got a whole kind of pitch on. If you go back and you look at the development of the GUI, for example, it's really quite interesting. So this is the graphical user interface. And I know I see we have a lot of graduate students on here that are younger. So you may or may not have this lived experience like perhaps myself and others. But if you go back and you look at some of the original, what predated the graphical user interface, it was a series of teleprinters and teletypewriters that were basically automated typewriters. And the information presentation in these systems were obviously sequential, printed line after line after line. And so when the first computer terminals, the first interfaces came along, that's how the information was presented, right? Sort of, it was all text, and it was all presented line by line by line. And that continued all the way into the 70s and even into the early 80s. Then we finally got around to creating some character-based displays, but they were really just sort of arranging the characters on the screen. They were still fundamentally ASCII text characters, but there was some spatial arrangement. And that continued into the 80s with like the Apple IIe and other and even the early DOS and even Norton's antivirus utilities early on of this form. And the interesting thing to me is, so I owned an Apple IIe, and I remember having to work at the command line interface, which again was an interface design that was driven by the early teletypewriters. And what did I do? Well, I did some programming, of course. That's how I ended up in CS. But I also played a lot of games, and because I was, a kid. And the games, they were all graphics. So this computer, this Apple IIe, had a graphics card. It could produce graphics, but the main user interface was still grounded in ASCII text. And so there was a technical capability to present a more advanced next generation interface, but it hadn't quite happened yet. And then of course, in parallel, there was work happening in labs at Xerox PARC and other places, and also to develop, not only the hardware, which I think people know about the mouse development, but also the kind of the Windows concept. But really, it wasn't until Windows 3.1 where that metaphor went mainstream. And so there was a gap, right? There was a gap between what our technical capability was in terms of presenting graphics and a new paradigm for an interface. And in that gap, we were applying what we already had done before, which was strings of ASCII text. Maybe we move them around to do something a little fancier. So this is the problem that I see, is that, I just bought a bunch of HoloLens too, so I love Microsoft, so I don't mean to speak disparagingly of them, but when you do have that first experience with a HoloLens, you notice, at least one of the things that I noticed was, one of the main interaction techniques is placing these two-dimensional planes in places. I can put a Netflix movie here, I can put a web browser here, I can put and then I'm just back to, having a bunch of monitors around me. It's still a two-dimensional GUI design framework. It just so happens that you can place it around you in 3 space. And that's not even getting into the interaction piece, right? Which we could talk about later. But the point being is that we're at a really interesting nexus, I believe. I think over the next few years, we're in that gap that I described earlier with AR. And so there are research labs that are exploring different interaction techniques, different ways of presenting information. I'll give a simple example. We're gonna have to pick 1 out of N items. Like when you fill out a form online, you've got to choose your state. You choose 1 out of N. Choosing 1 out of N is going to be a fundamental interaction technique, kind of no matter what the interface presentation is like. I'm not sure that we really know how to do that well yet in AR. And do we just use the two-dimensional version from GUIs or even from our tablets? Maybe. Is there a better way? Maybe. So I think people are exploring these things, but I think it's going to take some disruption and some innovation, and also more penetration of the hardware into homes before we kind of settle in on a set of standards. That's the bottom line, is that we don't have interface design standards yet. We will have them eventually. It's interesting for me to think about where they'll come from, because it's hard to even kind of, when you go back and try to figure that out for GUIs, you see that there are a few, like Apple and others, that were pushing interface design guidelines, and they still push those today in a good way. It'll be interesting to see who drives those. So we need those first, right? And then, and maybe some will come from the gaming community. There's a lot of really interesting interaction techniques and presentation metaphors that we see in the VR gaming space. They're probably, the best of the breed will probably evolve out of all, kind of all of the above. But okay, and I'll try to wrap this up. If I want to design a web page today, okay, I can go online and access any number of tools: mockups, Balsamic, Adobe XD, Azure, the list goes on and on. And when I open those tools, guess what I have? I've got a template or palette of objects and widgets that I can drag and drop to design. And those widgets are based on, I mean, some of them are even connected directly to, for example, Android's material design or iOS components. I mean, the interface design language is, for tablets, for example, or mobile, you know, is pretty well developed. And isn't that convenient, right? I mean, if you want to design a new app, and maybe you're a new designer, you already kind of can see what widgets might work well where, and there's even guidance. If you are a budding AR interface designer, you know, welcome to the Wild West. That's what I would say. So we'll get there, but we're not quite there yet.
Yeah, that makes a lot of sense. So switching gears slightly, you talked about talking to a colleague and observing people using AR, and you've also done work with aerial inspection systems. And so you've seen kind of firsthand and have explored firsthand what this new future of work might look like. And I'm just curious what you can tell us about that. What are the new types of jobs you expect? How will old jobs be redefined? Do you see positive, negative aspects from the perspective of, you know, the job, but also from the perspective of the people who are currently doing the jobs or future workers? How do you, what are your experiences having done this interesting work?
Yeah, so I think, you know, the obvious starting point, so I'm an AR researcher, so in my mind, AR changes everything. But I think the obvious, you know, starting point for this would be, you know, timely enough with COVID, you know, this whole distance problem or distance solution maybe. And so teleoperation, it has been for a long time a promise of AR. Some of the very early work you know, with video cameras and robotics was teleoperation. And so with the equivalent of Moore's law applied to AR hardware, and I don't just mean the display portion, but also the sensing equipment that's in the display that can sense the environment in real time. With that becoming smaller and more powerful, I think we're going to see a lot of interesting occupational opportunities in teleoperation, where we can outfit some robotic device, and a drone might be one of them, but we could also have, you know, little quadruped robots, or even larger vehicles that, for example, the Army Engineering Corps uses to clear roads. Those machines can be fitted with some of these same type sensor equipment, and then the operator is no longer looking at, you know, again, I think we're stuck in an old paradigm. The operators are no longer just looking at a video feed and trying to figure out, you know, what are my depth cues and how can I grab these things? But really instead, this experience is enhanced through a layer of AR interface and interaction. So I give an example with Boston Dynamics has this Spot dog, right? That they're now selling. And I don't have one. I kind of want one, but because I want to outfit it with AR if it's not already outfitted with such, but it might actually be. But the idea being is, let's say that you send in this teleoperated dog into a situation where it's not safe for a human to be. You know, if that robot is properly equipped with sensors and there are good interaction techniques and interface designs for the operator, you can easily imagine doing AR annotations in that scene that might be meaningful for a follow-up crew that is, you know, are humans, right? That also maybe have AR displays that come in, and the environment has already been kind of tagged and annotated. And so that particular type of use case is something that we're working on for NSF with our Future of Work program, using drones for inspection. So let me take our work and kind of broaden it to the what I see as some opportunities. So right now, to get a bridge inspection, somebody comes out, you know, maybe they block a lane of traffic and they spend, you know, they get these trucks that reach around the bottom, and it's a very manually intensive process. So imagine that you've got a drone that can do all of the things, that's semi-autonomous, that can do all the things that we don't really care to do, like fly it and control it. And right, we're human, right? We've got great eyes, we've got, you know, our experience, our knowledge base, and so we want to look for defects. The drone can fly the drone. We're going to look for defects, but we're embodied in this drone. So I don't necessarily need to be on site. So I could be in the middle of the US and I could be inspecting the Golden Gate Bridge. And you could argue that, man, that's a big bridge, and maybe probably the drone is smart, right? It's got some computer vision on board. It knows how to find defects. So maybe there's some downtime while the drone's moving from point A to point B, or when it's looking for the next defect for me to confirm or to look more closely at. So maybe I switch, right? So maybe I then switch to, one of the bridges in New York. So what does that mean, right, for an operator? So yes, I can teleoperate or tele-inspect, but how many bridges am I inspecting at any given workday? And even when I go to the Golden Gate Bridge, maybe there's not one drone, maybe there's multiple drones. So I think there's some promise in the sense that we can do this work remotely and more safely, and have assistance from robots instead of having our job replaced. We have assistance, but also how do we balance, right, just the load, so that we don't, we now know what it's like to be stuck at home. So we're like, we don't want to work from home anymore. But imagine that, you wake up and you're inspecting bridges all day from your home, and it's extremely taxing because they're given too many bridges and too many drones. I think that's, so that's that. I think that's part of that's part of it. I do think there's a lot of folks, for example, Doug Bowman at Virginia Tech, who is a great colleague of mine. His group is looking at knowledge work via AR. So, we use Microsoft Word or Google Docs to do knowledge work, right? We're academics. That's kind of what we do. How can we use AR for knowledge work? And his group is looking at a lot of interesting questions and coming up with more to look at. And then obviously, you and others are looking at how AR can support working on the go, in some kind of transport or mobility scenario. So I do think the future of, and then, then of course at the lowest, I don't want the lowest level, but at the most, at a level that's most congruent to how we work today, even like a construction site, there's obvious ways to enhance the situational awareness of workers that are already on site doing the things that they do. It's just that they have additional information that's presented via AR instead of through traditional means. So I do think AR has the potential to penetrate and change work, either incrementally or even fundamentally, but it'll take time. I mean, we have some important issues to address, right? So for example, in the example I gave where you're sitting at home inspecting bridges, well, what am I using, right? Am I using a VR headset? Well, if so, am I going to get sick? Am I going to get motion sick? Probably. So maybe the AR isn't immersive like that. Maybe I have a bunch of screens, but we don't know how to balance all that yet. And we don't have the devices. There are some, I meet more and more people that have VR headsets at home for gaming that aren't VR researchers, that just bought them for fun. And that's encouraging, but we have a ways to go still.
So thank you, Joe. We have some questions from the audience, and I have a questions that I'd like to start with. So we're thinking about, right, the changing jobs and how people perhaps will do inspections and teleoperations from their home or from remote environments. One question that I have is, what are some of the human factors that we should consider, right? I could imagine that inspecting bridges currently have a physical aspect to it. Like you walk around the bridge, you look at different places, you move your body in certain ways. It's a job that involves physical inspection. Sitting at the home office and doing that all day has very different ergonomic aspects. So I'm kind of thinking, what are some of the concerns about the physical aspects, the human factors aspect of the interactions that you have?
Well, so, I'm going to probably do something that's probably not advised, but I'm going to caveat my answer on the front end by saying that I don't study biomechanics and that I have some loose exposure to it. So for me, I can so we don't, right? So here's some things that we don't know. I mean, so there's been a handful of people that have kind of donned VR headsets for long durations of time, and so we know a little bit, but we know very little, right? And that's only a couple of people. It's not the broad population. So we don't really know what longitudinal exposure to stereoscopic artificially generated images or stereo feeds with latency. We don't know what this is going to do to fatigue, but like physiological eye fatigue is what I'm thinking, physical eye fatigue. So amongst other things, and I can say also that my restriction of motion here at my little desk in my spare bedroom, to me, there's another piece that doesn't get talked about often, which is the connection that we have between our body movement and our cognition. Margaret Wilson's work on embodied cognition. I miss standing in front of a whiteboard with students and discussing design ideas, not because I don't have a shared whiteboard to work with them. We can do something similar on the computer, but just that movement and the gesturing and kind of pacing around and thinking gets, there's affordances with that, but we don't have the same at home. So I think it'll be, I think maybe we can probably borrow best practices and guidelines from occupational settings where workers, are limited in their ability to be mobile, whatever reason, and there is a whole 100 plus 200 years of that work that we can leverage. So I would say start with that. But ultimately though, I do think, I think the future of interfaces, be it AR or other, is highly personalized and adaptable, and they learn from me. So instead of me setting preferences, the interface can observe what I'm doing and be smart enough to adapt. And that way then, as my physical or cognitive abilities, either decline with age, decline because of a disability, or maybe accelerate due to training, as my behavior changes, my abilities changes, the interface changes. It's just some thinking that I've done. I don't know how we're going to get there, but I do believe that's the future of interfaces. It won't be a one size fits all, because it's, excuse me, for me, I think it's fascinating that everyone in the world, not everyone, but many people, many people know what a left mouse button does. To me, that's fascinating. It's like we trained the whole world to click on the left mouse button. And I think that's done. I think in the future, it's going to be, I'm going to interact with an environment, a system, a digital interface in the way that makes sense for me. And although there may be a learning curve for the machine, not for me, it'll be the interaction will eventually be individualized, and hopefully that will assist with some of these both physiological and cognitive challenges.
Thank you. And I think that's kind of Alberta's question is connecting, but has a slightly different focus. Alberta, do you want to ask your question?
Yeah, sure. I was curious as to what you think we can do to make AR and VR a more natural experience, because you did talk about the fact that the design phase is not up to par with the evaluation phase. And I'm just wondering, how can we make it a more natural feel?
And thank you, Alberta. And maybe kind of prior to answering, Joel, kind of ask Nadia to add to this question.
Yeah, thank you. So Alberta's point made me think like the next left click for AR, do you think it's going to be something natural or something that is going to be taught? Because like we see that like the interactions with the first HoloLens, like the click or the bloom, they're not the things that like first come to mind as we think about interactions. And like, or like with Google Glass, like that touchpad that's next to the right on the head. Like they're so unnatural. Like, yeah, I was thinking like, is it something like, are we striving towards being natural or like easy to teach interactions?
Mm-hmm. Mm-hmm. That's good.
Thank you,
Yeah,
Alberta. Yeah.
both perspectives are, yeah, interesting. I don't know if, so my wife says that I'm a parser. Maybe this is the computer science in me, which means that I parse sentences and words instead of like focusing on the intent. So you said, are we? And I'm glad to hear you say that, because I hear people say, oh, I wish they would invent blah, 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 or I wish they would do this. No, look, they are scientists. We are scientists. This is on us, right? So when we say, are we striving for, or are they striving for, it's we, okay? We're doing this. So what are we trying to do? And we're all the above. Like, I think we don't really have a unified response yet. I mean, obviously, a naturalistic interaction seems like a laudable goal. In fact, we ran a quick study with a small number of interactions, like clear a screen, bring the screen back, move an object. And we brought in folks and we did a Wizard of Oz study, and we said, do whatever you want. And we gave them, we didn't even really say what the boundaries were, which was difficult to script, by the way. But anyway, so they could use voice, they could use gesture, they could use, this was for the DoD, so they had things in their hands. And so they could do anything they wanted. And we found some interesting patterns. People, when you want to clear the screen, get the screen out of the way, people kind of do this, like you're knocking a bug out of the way. So I think we can look at different naturalistic interaction techniques, but I think the challenge becomes, and maybe interaction designers that are in industry that do this for a living would say this is not that hard of a problem, but obviously the challenge becomes there's a whole bunch of interaction techniques that are required, and then do you train everybody, or do you more appropriately respect cultural differences and try to work those in as well? So I think right now we would be happy with something that seems to be better than worse. So I know people that have the clicker are like, I don't do this anymore. I just use the clicker because it's just more efficient, even though maybe not less natural. And it may be with, it may be that we need a device. I mean, it may be that we need. I was thinking the other day, I know there's been ring devices, but just we can't be ergonomically positioning rays all day long. We can't be ray casting all day long. That's just not going to work. So, yeah, I don't know. I can tell you this. Sometimes the most natural way to do something, though, isn't always the most. It may be the most intuitive to learn, but it may not be the most efficient. So we'll have to kind of balance those things out as we move forward.
Thank you. So there are a few more questions about natural interactions, but I want to take a pause from natural interaction and think about how we evaluate interactions. And Jawan had a question about evaluation. Do you want to ask the question?
Yep. Can you hear me?
Yes.
Yeah.
Yes.
Thank you for your talk. Could you explain how you measure the satisfaction in detail? I mean, when I conducted some pilot study with the HoloLens, with the Microsoft Remote Assist, most participants answered positively, like that's cool. Yeah, it's kind of a promising technology. Yeah, I might be gonna use this technology if I keep using them. But I thought this was because no one has ever used the HoloLens, so they might have been hard to evaluate their experience because it looks cool.
Right. Yes. Thank you for that question. Yeah, I mean, what you're alluding to is the novelty effect, right? And there was a time, I think it was maybe a year or two ago, where I spent like a month thinking about this, and I was like, all the studies we do are like just 45 minutes of exposure to a stimulus. So unless you're doing some low level, psychophysical, detection threshold type study, if you're doing like kind of an interface or, how happy or content am I with an interface? I mean, can we really know that after 45 minutes? And then you think about all the papers. So, I mean, the vast majority of papers bring people in for less than an hour, and that's the foundation of our science. And so I was like, okay, now and then I worried myself, and I was like, okay, every study we run, we're going to run like longitudinal now, which of course has its own baggage. But to get closer to your question, in the UX class, we talk a little bit about meaningfulness of an experience with a product. And the bottom line is that you can't measure something like how meaningful a product is without longitudinal studies. So these would be studies where, you have diary studies from home, or you've got some way for people to, fill out a form periodically or whenever they have some experience that's notable, positive or negative. But, so it's got to be something like that where your participants are able to experience, in an optimal world, they would be able to fold it into their life and use it every day. And then you can really get to the heart of what makes this interface design meaningful or not meaningful, which is kind of impractical in a lot of senses, because we can't send, most of our interfaces aren't designed to be used every day yet, because we're not product makers, right? We're making test beds. And also you just can't send devices off willy-nilly and hope that they come back a few months later. So I guess if you're getting, I mean, you're trying to get to a subjective measure of a preference, like do they like the system, or what exactly are you interested in measuring?
I asked the experience. Yeah, actually, I tested how well communicated between the collaborators using the Microsoft Remote Access. So, and how did the interface was easily used in your case? Something like that.
Okay. Yeah, so I think, earlier I said, I think we know more about evaluation, so I need to back that up. So, right, I think you can take extant questionnaires and surveys that are out there. Those, have been validated and should be good to go. There are some techniques that are a little bit different if you want to measure a specific aspect of an experience. And this is an example I give in the usability engineering class that I give. Mm. So I worked with a UX company out of Columbus, Ohio, that was designing this is a car example, so Andrew's gonna like this. They were designing the in-vehicle experience for, I believe it was Buick, might have been Cadillac. Anyways, I think, and they found out through their user research that, and from branding, that luxury was important. And so like, okay, so our design philosophy is going to be luxury. And so then the designers are like, well, what does luxurious mean? Right? And so that, well, we got to figure that out. So there's a whole process for figuring out and operationalizing what does luxury mean in this design context. And then the beauty of this process that they went through is after they designed their in-vehicle information system, and I think there were other elements of the vehicle that were designed to be luxurious. They were able to derive a set of metrics and questionnaires from that same user research to be able to measure, did we get to, how close did we get to luxurious? And so you can use extant surveys and tools to measure things that are kind of common, like ease of use or usefulness and others. But if you have something specialized, know that there are ways to work with that as well. It just requires a little bit more work.
Thank you. Hijin has a question. Hijin, do you want to jump in and ask your question?
Sure, yes. Can you hear me?
Yes, thank you.
recently I'm interested in the 3D scanning using some commercial RGB or LiDAR sensors to create holograms. So I wonder, Dr. Joe, you have experience on holographic sensors, and I want to know what the benefits and challenges on each of those sensors, if you have.
So when you say holographic sensors, you mean sort of RGBD depth mapping cameras?
Yes, right.
Yeah, so let me, okay, Andrew, I told you I was going to share a screen, and I haven't done it. I haven't done it yet. So with your permission, I just want to just share a video really quick, because I think this is kind of spot on to, so this is something that we just finished. This is for head worn, but we can attach this to a drone too. I haven't made the video for the drone yet. But this is the idea, is that we've created sort of, with RGBD cameras, we've created this on-the-fly spatial, lightweight, what I call lightweight spatial mapping, because we're interested in just mapping just enough of the information to present meaningful AR interface information. We don't necessarily need to do a full reconstruction, you know, later. I mean, that's a nice to have, but I'm looking for speed more than sort of accuracy, because we're just kind of placing interface elements. And you know, if I'm annotating a bridge, this would be useful, or if I'm doing a first responder scenario, this would also be useful. And then, you know, I made this video for NSF, so I could, you know, to show that we did some stuff, right? So this is sort of the annotation piece. But the challenge is, right, so here's, let me finish closing here, or stop sharing. So, okay, I'll say something that I say a million times, because that's how my brain works. AR used to be, you had to estimate your head pose with really great tracking, and if you needed to have a priori knowledge of the spatial environment, and then your head pose had to be completely accurately registered with that a priori knowledge, or if you placed graphics places, it would look weird. Like the cat wouldn't be on the table, the cat would be floating above the table. I love where we're at now. This real-time spatial mapping, LiDAR, RGBD stuff, this is so awesome, because I'm now subscribing to the fact that we don't know anything about the environment, and that's great. Like, we don't need to. In fact, I don't even necessarily care. I mean, for other reasons I might care, but for annotating that scene, I may or may not care what the exact GPS coordinates of all my vertices are. I don't care, right? I just want a mesh that's perceptually meaningful to our user, and to me, that's kind of liberating. Now, what you just saw can't be done with the HoloLens because of the interference with IR. My HoloLens 2s are in a box still, so I can't go get them yet. I don't know if it's any better. I think it's probably based on the same technology. We're using a Z Mini for the work I just showed you. So I think some of the challenges there, right, have been it doesn't do well with glare. The sensors don't do well if you swing the camera too quickly and it loses kind of track of this part of the scene. Is it connected to this part, and how is it connected? But again, I have the highest confidence in our other scientists and engineers of the world to make better Zeds quickly. And then the other challenge is streaming that video and the mesh data, because it starts off as point cloud data, right? You've got to try and getting all that off of the drone and back to some computing power. That's, you know, you can put Jetson on the drone, but that's going to only get you so much. So we have bandwidth issues, and we're hoping 5G will help with that. But I think we're getting closer. I think we're getting much closer. So challenges are, you can't cover, distance is an issue. I guess LiDAR helps with that. I haven't worked directly with LiDAR. I follow it loosely. But I guess, so this has been my philosophy with tracking since the beginning of time, is A, I don't do tracking, even though I just showed you a video. B, I hope others do tracking. And C, I only need tracking to be as good as it needs to be for my problem. Luckily, I mean, I don't do surgical AR, so I don't need crazy precise tracking. Surgical AR does. So think about that. Think about that. Think about, you know, what fidelity of tracking do you really need? What, you know, what fidelity of mesh do you really need to do what you want to do for your research?
Thank you. So we have one last question about interaction design. Alberta?
Yeah, interesting discussion so far. I was just curious as to how much of what we see on TV and in movies would influence the interaction on AR.
No, thank you. That's also a good question. Well, you know, it's funny because in this, I'm flipping through one of the talks I have so I can get this right. Yeah, so in 1901, there was a book written about, it was a short story actually, and it was for boys. And it foreshadowed a number of different concepts, right? So there was a taser, the idea of a personal force field, a personal assistant like Siri with live video streams. It translated and also overlaid kind of information, glasses that could overlay information in the real world. This is a book written in 1901. So there's no doubt that pop culture is connected to what we're doing, at a minimum, sort of indirectly. You know, it's not clear to me how much movement there is and sharing between, for example, the gaming community and the designers. There's some, it's probably not prevalent, but there's some. You know, we're, like I said, we're in the wild, wild west here. And, you know, I have on my list of things to do to figure out where the gesture input that's now common on, you know, that was kind of kicked off with Apple, where that came from. Because my gut says Apple didn't invent all of it. You know, pinch to zoom, so natural, right? Where did that come from, right? Was that done in a lab somewhere? And then Apple just kind of like had the right touch screen at the right time and the right market penetration. So my guess is that we will be inspired, we as designers, and I'm saying we, not they, will be inspired by all sorts of sources. And I think pop culture will be one of them. And why should it not be? You know, good ideas come in many forms, from many places, expected and unexpected. So I would say, you know, let's embrace all ideas from all directions and see where we land. But I am, you know, I'll say it one last time, and I know I've said it like 10 times now. You graduate students generation, you guys are going to be the ones that are going to solidify what AR interaction looks like. It's going to happen in the next 5 to 10 years, and you guys are at the age bracket where you're going to be right in the middle of it if you stay in the field. So don't disappoint me. I know you'll do great.
Very nice. Very nice. This was fun. And I want to point out actually that many of the people on the call today are actually undergraduate students, not only graduate students.
You're in this
lab. Yeah. So, but I think that perfectly covers the age group. So
good. No, there's some exciting times ahead, for sure.
Joe, this was fantastic. This was really, really good. I mean, every time I talk to you, I learn things. So thank you for spending the time with us. This was really, really good.
You're welcome.
And I quickly wanted to mention that if you look on our website, we have a couple of exciting talks coming up, or conversations coming up next week and then the week after. Next week, we will be talking about an AI-powered future that works for vocational workers. So we discussed that to some extent today with Joe, right? So many of the jobs will be affected in various ways, and I think this is going to be an exciting conversation. And then a week from that, it's going to be AR, VR, and the future of work. So good plans ahead. Thank you again, Joe. I really, really enjoyed this. And I'm going to stop recording now, and we can stay on for a few more minutes.